The one thing that divers need to feel absolute confidence about when they're underwater is what's in the tank. Any mistake with the pressures or mixture of gases could lead to very difficult situations. Getting it wrong could even be fatal. The principles of partial pressure are important for lots of reasons, not just scuba. So let's dive in. This is Real Chem. Understanding partial pressures allows chemists to predict the behavior of reactions involving mixtures of gases rather than pure gases. These principles are used to better understand atmospheric changes, sustainable energy storage, and transfer systems, like fuel cells and carbon capture. So these ideas are important. Vamos a mirar juntos. Let's explore. An amazing thing about gases is that the pressure depends only on the number of particles in a container, not the mass of the particles. Consider two containers of gas, each with the same volume and temperature, but one containing argon and the other containing neon. Say we want both to have the same pressure. How can we accomplish that? We just need to put the same number of gas particles into each. It does not matter that the mass of argon is 10 times that of neon. Cool, right? This makes it easier to think about gases, and especially mixtures of gases. Now, say I mix argon with neon. I keep the total number of particles the same, but half are argon and half are neon. This mixture will have the same pressure as the container with pure argon and pure neon, because pressure only depends on the number of particles, not their identity. It even makes sense to say that half of the pressure in the mixture is due to the neon and half is due to the argon. If that makes sense to you, then you know now what is meant by partial pressure. Let's say the total pressure of this mixture is 1 atmosphere. Then 0.5 atmospheres is coming from the neon and 0.5 atmospheres is coming from the argon. We can say the partial pressure of neon, P of neon, is then 0.5 atmospheres. And the partial pressure of argon, P of argon, is 0.5 atmospheres. The total pressure is the sum of these partial pressures. Pressure of neon plus pressure of argon is 0.5 atmospheres plus 0.5 atmospheres is equal to 1 atmosphere. Now, suppose you decide to go diving, and your scuba tank has a total pressure of 150 atmospheres, which is 32% oxygen and 68% nitrogen. What do those percentages mean? It means 32% of the pressure is coming from oxygen for a partial pressure of 150 atmospheres times 0.32 is equal to 48 atmospheres. And 68% of the pressure is coming from nitrogen. The partial pressure for nitrogen is 150 atmospheres times 0.68 is equal to 102 atmospheres. From our understanding of partial pressure, we also understand that this means 32% of the molecules in the tank are oxygen and 68% are nitrogen. If you look at the label on the tank, you may find it says the tank is 32% oxygen by volume. This is because we could imagine all of the oxygen in the tank being at the top of the tank and all the nitrogen being at the bottom. The oxygen would then occupy 32% of the total volume. Of course, the gases are actually mixed, but we can still think of oxygen as occupying 32% of the volume of the tank. Just like a diver preparing for a swim, be prepared to double and triple check your partial pressure calculations. And always keep in mind the basic principles at work when we mix gases. And if you're a diver, maybe also check again one last time. Vamos a explorar y no se te olvida tener fun. So explore and remember to have fun.